Good morning. Good morning to all. Am I audible? Hello.
Yes, you are audible, sir.
Okay, thank you. Uh, um, do you know how many students in this batch? All of only 10 join, I think. If you have any WhatsApp group or any private group, you can message them to join. Uh, so, as you know, I will teach your two paper MCS 230 and 231. And today I will start mm, uh, digital image processing. It is your MCS 230. So digital image processing, mm, actually it is a concept or branch of computer science, uh, which help us to process an image. You know that nowadays the digital image processing has a high demand. So read this side, that is one picture is worth more than 10,000 words. Uh, are you agree with this sentence? Anyone? One picture is worth more than 10,000 words. So that is graphically represent it. It means the graphical representation of anything tells more than if you write in textual manner. If you write any text, so that is it is better you make them as graphic or pictures. So uh, you know, the one picture is worth more than 10,000 words. Let us start. What is the image is? What is an image? Uh, Image is nothing but it is a representation of something or someone. For example, any drawing, any painting, any photograph, any graphics, anything. If you depend of something or someone, it is known as an image. You see here in our picture, there are two types of image of flower. One is a color is black and white, and another contains some colors. So, image are very powerful. Uh, Image are very powerful tools in communication. So um, that is image is very powerful in communication. Basically, it used in communication. Take an example. Suppose when you are driving in a road. Suppose you that is all the symbols, the traffic symbols. You know they are as represented by some graphics. The text is not written there. The graphics are there. If there is a turn, there is some arrow sign. If there is a humps, there is some zebra sign like that. That is it is a powerful tools in communication. That is you will you can view it and you can understand that why it is used. It may be black and white in color. So a image can have multiple colors, or it can be represent uh, in black and white color only. So as our topic is digital image processing, the image is nothing but is representation of something. What is a digital image? A digital image is a representation of two-dimensional image has a finite set of digital value called pixel or picture element. So it is a representation of a two-dimensional image. That is, as two-dimensional, all the picture here in digital image is a combination of two coordinates. One is x and y coordinate, and it associated two values. So that is why it is called two dimension. Some value in x coordinate and some value in y coordinate. So that is why it is called a two-dimensional image. Uh, and besides that, it contains some finite set of digital values, which is called pixel. You may heard about the pixel. This is your camera this mg pixel, 8 megapixel, gigapixel. You heard about that. So pixel is nothing but it is known as the picture element, and it is a smallest unit of digital image. You cannot divide a pixel into smaller parts. So you see, when a image is represented in a computer screen, so it is a considered as a digital image. You see here, pixel value typically represent gray labels. We'll discuss about what is gray labels, colors, height, and opacity. These are different characteristics, different type of component. We will discuss about that. Digitalization implies that a digital image is an approximation of real scene. So there is a when you represent an real image, you need computer screen. So it is form of a digitalization. So mathematically, when x y and f of x y, that is it. You now consider it is a function of x y. Uh, are all finite discrete quantity. We call the image a digital image. As I discussed, an image consists of two quantities, two components. One is x and y, that is its location, and f of xy, the intensity of that value at that location, f of xy. So I am discussing again, I am explaining again. As a digital image, a two-dimensional image, it must contain two values. If you tell two-dimensional means it must contain two. What those two values? One is location. One is location. As you know, each digital image is a consist of a pixel. That is the location of the pixel. Another is the intensity of the pixel, the gray level value of the pixel. So that is why an image is known as a digital image, as it is a two-dimensional image. It contains two values. One is the location and the intensity or gray level value of that pixel at the point xy. That is xy is the location of the image, and f of xy the intensity of that pixel or gray level values of that pixel whose location is xy. So digital image is composed of a finite number of elements, each of which has a particular location and a value. So the summary of the discussion is, so far, each image is consist of a finite number of elements, which is known as picture element. Sometimes it is termed as image element. Sometimes it is known as pixels, which is widely used. We are it is not a new term to us. So pixels, and sometimes it is known as the pales. But pixel is mostly widely used. So each element contains a digital image composed of finite number of elements, and that element is called the pixels. And pixel, every pixel is associated with two components. One is its location and value of that pixel at that location. Shortly written as the value, the location and the value. Value means the intensity or grade level values of that pixel at the position x and y. Are you getting? No answer. You see this image, you will be more clear. An image is defined as a two-dimensional function for f of xy and xy, where x and y is the spatial plane of coordinates. That is, you can tell it is the location of that pixel, and f of xy, the gray level value, the amplitude of f, intensity value. You can tell it the intensity value or gray level value. So you see the first picture. Uh, the point of x0 y0, you see the point where two lines intersect, two red lines are there, and it intersect at a single point, and that point, the coordinate of that point is x0 y0. You see the coordinate of that point is x0 y0, and the intensity of that pixel, which is at x0 y0 is f of x0 y0. x0 y0 का जो इंटेंसिटी है वो f of x0 y0. Similarly, in second picture you see there's another point, another pixel of that digital image, but whose location is x1 y1, whose location is x1 y1, and whose value is f of x1 y1. So you see x1 y1, where the two lines intersect, the location of that point is x1 y1. So the location of that pixel x1 y1, and the intensity value, we will discuss the what is the intensity value, what is the gray level values, and what is the range of the gray level value. That is f of xy, f of x1 y1. Suppose the location of x1 is 2 3 and f of xy value is 100. So 100 is known as the gray level value of the pixel which is available, which is located at the point x1 y1. So these are the image, and there are two pixels at one is at x0 y0, the in the first picture, and x1 y1 in the second picture. And whose intensity value is f of x0 y0 in the first picture, and f of x1 y1 in second picture respectively. So as we discussed, an image is a two-dimensional object, so it contains two values: the coordinates value x and y, and f of x and y, the gray level value or intensity value. Types. The image can be classified based upon different components. So the first component is here, attributes. You see the classification of image on basis of attributes. There are two types. One is, you see, vector files. The vector image or vector image files are most useful when a graphic need to be able to handle resizing, as they retain crisp detail when the scale to any size. So vector format is an excellent choice for digital illustration such as logos. A vector file can be converted into raster file, but it will permanently lose the advantage of the vector format. So a vector format, if the picture is vector format, so basically it is most useful when a graphic needs to be able to handle resizing. And a vector can be converted to another side, another type, that is your raster side. We'll discuss about that, the raster file, but it will permanently lose the advantages of the vector format. Some example of extension of the vector image are SVG, EPS, and EMF, Microsoft Office based vector format, and Adobe based vector format is EPS, and SVG web based vector format. When we will see this extension, give any file name, so you know that they are the vector files. The other files which are more familiar, the raster. The raster image are best for complex image like photographs, and are more likely to be widely compatible file format, basically our JPG format. We are familiar with the JPG format. However, raster image lost details and become increasingly blurry when enlarged. So we know that when a photograph is enlarged, so it pixel size is increased and it becomes more blurry. Although a vector image can be saved as a raster image, it is not possible to make the vice versa. That is, it is not possible to convert a raster image into a vector image. Raster file saved as vector file format will still be raster files. Most images on the web are raster files. So common extension that we are familiar is JPG. It is compressed raster format, often used for JPG. We know that JPG, PNG, and JPG compressed raster format, often used for photos, best for web use, small file size, and these are the advantages of JPG file. It is universal compatible with most of the software, and most image on stock photography website will be downloaded as JPG files. So some PNG file are raster format good for illustration of icons, supports transparency unlike JPG, best for web use, small file size also. So these are the some extension of raster files. And another file, TIFF format, raster format, that is the best of high resolution printing. So great for professional print use. That is, suppose you are printing a flex or a professional printing like that, especially when preserving this image, that is important. And unlike the previous two, the file size is large here. So based upon the attribute, uh, an image can be classified in two types. One is vector, another is raster. So based upon the color, also the an image can be categorized into different component or different subcategories. That is monochrome image, are the image where the color component is absent. They are further classified into grayscale. We have just discussed about the gray label value. Gray label value. What is gray value? You see the grayscales, or it is often referred as binary image. Grayscale image. The term grayscale refers to the range of the shades between white and black, or vice versa. So the gray scale imager, it is contains on, you can, in other word, you can tell it is a black and white pictures. The different intensity are there. The where the black color intensity is more, the white is less. It may be, but the you can tell it is a black and white uh, image or monochrome image, and sometimes is known as binary image because it contains two values, black and white. So that is why it is called binary image. Such an image have many sets of gray and 8 bits, and maximum 2 to power 8. 256 are enough to represent the grayscale. So grayscale contain 2 to power 256. It is 2 to power 8. It is not 28. It is 2 to power 8. 256 values are there. So 256 different values are they are in gray level values. It is ranges, as I discussed. There are some ranges of the gray level values, as you know. And digital image consists of two values. One is your location and the value. These are the value whose value is a two different 256 different values can be assigned, and it ranges from 0 to 255. Total 256 different values. So the human visual system cannot distinguish more than 32 different gray level, as there are 256 gray level values, but we can uh, uh, the human visual system can only distinguish more than 32 different gray levels, and the additional bits are the necessary to cover noise margins. And the most medical image, uh, the X-ray. You may seen the you may have seen the X-ray report of a patient. It does not contain any color. It contains only black and white color. But you see that black and white color are different intensity. Where the black color is more deep, where the black color is not so deep. It is a lighter. So similarly, the white color, the intensity are not same as in each place, each location of that image. You may recall a CT scan report or a X-ray report of any patient or MRI report of any patient. You don't find any other image. Or, sorry, you don't find any other color. There is no black, red color. There is no yellow color. There is no blue or green color. But it contains only two color, black and white. But another important thing is the intensity of the black color is not same as each location of that report. In some places, the black color is more deeper or white color is more lighter. Similarly, in other places, the black color is more lighter. So you will find the different value. That is called the gray level value. That depend upon the gray level values. Where the gray level value is less, it is more deeper. Where the gray level is higher, it is more lighter. So as you know, the gray level value lies between 0 to 255. Total possible gray level value is 256. So gray level value depend upon ranges from 0 to 255. So the pixel which have low gray level values, it is more deeper than the pixel having high range values. The binary image are just special case of gray level image, where the process of thresholding is applied. We'll discuss about the thresholding. We have a transformation thresholding. We'll do clipping thresholding. We'll discuss. But a thresholding will where applied, they are actually bi-level image where the pixel are zoomed to 0 or 1. That is, you will find either 0 or 1, either white or black. You will not find any other color. Or other color means no intensity of the other color. So either totally black or totally white. So 0 stands for total black and 1 stands for total white. So that is called the binary image. You will not get any other intensity of black and white. Only one bit is sufficient to represent the pixel value. So every pixel value, as you know, the pixel value ranges from 0 to 255. It may contains 256 values, but In case of a binary image, it only contains two values, either 0 or 1. So 1 bit is sufficient to represent it because it contains either 0 or 1. So that is why 1 bit is sufficient. There is no third option. So either 1 bit, it contains either 0 or 1. So that is why it is written that only 1 bit is sufficient to represent the pixel value. Because here no 256 values is it is not required here. As it is called binary image, it one pixel contain either 0 or 1. So 0 stands for totally black color, 1 stands for white color. So far we have discussed what is an image is, what is a digital image, what are the component of digital image, and what is the classification of some image based upon some attribute, based upon the content. But what our topic is digital image processing, DIP. So what is that? Digital image processing. So processing of image which are digital in nature by a digital computer. So sometimes an image needs processing. It has to be processed. Needs processing because to enhance its quality, to get more information. So it needs processing. Suppose there is an image. Suppose you consider this, there is a tiger, the image of a tiger. But I am interested to get information from the eyes of the tiger. But I have a picture of a tiger. But I am interested only to get some information from the eyes of the tiger. So I have to take that part of the image only the eyes. I'm not interested in the other part of the that tiger. So it need to be processed. And suppose I have taken a uh, photograph, and that photographs the quality of the photographs not seems good. Okay, so it needs to be processed. So processing of an image, a digital image basically, by a digital computer is known as digital image processing. So what are the motivation? What are the need of processing? Improvement of pictorial information. So and efficient storage and transmission, etc. Efficient storage. A digital image takes less space as compared to its corresponding analog image. So it takes less storage space, less memory, and as it takes less memory, after processing, it is easy for transmission. As you know, a file having less size uh, is transmitted fast. So these are the two motivation, that is why the image processing is required. The improvement of pictorial information. Any information you get, it needs some processing. As I discussed, I am only interested to get information from the eyes of a tiger. So I can enlarge it, I can cut it, I can crop it, so I can find it, crop it, and I can only take the part of that image which I am interested. Suppose I am, and second is efficient storage. As you know, after processing, you can also decrease the size of an image, so that it can be transmitted easily. You can send from one computer to another computer easily. So there are some more definition. Image processing is a method to convert an image into digital form and perform some operation on it. So as you know, the processing is associated with the digital image. So if the process is if the image is not digital, so first we have to convert it digital. Once it is converted to digital image, so how there are different methods. We'll discuss that how the method is converted. But once it is converted, you can perform different operation. You can increase the size. You can apply some technique to improve its quality. If there are some, if the picture is blurry, you can improve its quality. And if contains some noise, if it contains some noise, you can also remove them. So in order to get an enhanced image or to extract some useful information from it, we can perform some operation on a digital image, and this is known as the digital image processing. It is a type of signal dispensations in which with input image or output may be image or characteristic associated with that image. So sometimes it is converted to some image. We'll discuss that some signals. It is among rapidly growing technique today with its application in various aspects of a business. Image processing forms core research area with engineering and computer science discipline too. As you know, the DIP, digital image processing, has many applications nowadays. The application of this DIP is large nowadays, so it can be used in various aspects of the business, in engineering and computer science disciplines too. So digital image processing focus on two major tasks which I've already discussed. There are some more things is there. Improvement of pictorial information for human interpretation. So if you want to get some more information, you can process an digital image. Processing of image data for storage, transmission, and representation for autonomous machine perception. Uh, some argument about where image processing ends and fields such as image analysis and computer vision start. You can write your name and your registration number, enrollment number for the attendance in the board. You see here the image processing labels, types. You see low level process. The input here in low level process is an image. The output is also, you will get another image. It may be a enhanced image, a better quality image. The example is noise removal or image happening. So if we make, suppose if an image contains some noise, and after removing, uh, you will get another better image, better quality image. So that is known as low level process. Only noise or image sharpening can be done there. We'll discuss how to noise, what is noise, what is the type of noise, and image sharpening method. We'll discuss that in later slide. But if we done that, that is if we remove some noises and image happening were applied, so this is called low level processes. But you see the middle level processes, the input are images, output are attributes, object recognition and segmentation. This is also the another techniques we'll discuss. But in high levels, the input are attributes and output is understanding. So these are the example of scene understanding and autonomous navigation. So these are uh, the different levels of image processing. So sometimes you get of the question the purpose. So what is the purpose of image processing? The purpose of image processing are divided into different groups. You see, visualization. Observe the object that are not visible. Sometimes it contains some noise or due to any reason. So it is not visible, it is not clear, but so you can improve the quality, image sharpening and restoration to create a better image. So image sharpening is another technique used to get a enhanced or better quality picture. Image retrieval, seek for the image of interest. So you can retrieve the only part of the image which you are interested in. As I discussed, we are only interested of eyes of a tiger. So I can retrieve on that part, and I can only get some information from that part only. Measurement of pattern measures various objects in an image. So suppose you are searching a particular object in an image. Suppose a doctor is searching a brain tumor in a MRI report. Okay, in a MRI report, you are searching for a brain tumor. So here that pattern should be measured, or that is searches that pattern only. Image recognition, distinguish the object in an image. Suppose you are only interested of the vehicles in an image. There is a large image, and you are searching. You are distinguish this object. Some part of the vehicles, some are trees, some are humans. So you can also distinguish the object in an image. The different type of the an image contain different type of object. So you distinguish them. So these are the different purpose of an image process. So so far what I have discussed, what is an image, what are the types of image, what are the digital image, and what is the image processing, digital image processing, what are the purpose of different image processing, and now what is the method. As you know, there are analog image processing and digital image processing. So we are not concerned with the analog image processing. It is not in our course. In this type of processing, the images are manipulated by electrical means by varying the electrical signal. The common example include in the television image. And digital image processing. It helps in manipulating of the digital image by using computers. The three general phases that all types of data have to undergo while using digital image: pre-processing, enhancement and display, information extraction. So as you know, these are the already I discussed. These are the purpose of a digital image processing. So we are associated with digital image processing. Uh, Let us see. You see, there are some graphics. You see, let one represent white, zero represent the black color. As you know, one represent the white color and zero represent the black color. Uh, you see, there's a written as a T. You see, the digital when we make digitalism, it is from a number zero and one. You see, Now you mark that 0 is a form of a T, that is a UV. If you start all the, if you find the location of the 0 and you see all the zeros form a letter like T, so it contain black color because T is a black color here, and the other color is a white color, so it is represented by 1. As it is a binary image, only two color is visible, 1 and 0. The other intensity are not visible are there, not written there. So either it is 0 or 1. 0 stands for black color and 1 stands for white color. So as you know, the digital image has a value. So value must be a number. It is not a fractional number, it is an integer who ranges from 0 to 255. But in case of binary, it is either only 0 or 1. You see here, there's a picture of a like a skeleton, you see. And when the for you see written for human view and for computer system, when you view the image looks like a skeleton, but you see for the computer system, the computer does not see it. It does not have any eyes like a human, but it contains some values based upon that image of that image. And you see there are some values 56, 57, something written here. See, you see some integer, you see there are see there that are the different gray label values of that pixel of that image. It is these are the gray label values of different pixels of that image. So you can find the difference, how the data is stored in the computer in the form of this value. So a digital image contains some values. As you know, it contains two parts: a location xy and f of xy. This is the f of xy, the value is written there. Then digitization of an image. As you know, an image must be in digital form for processing. So before processing, the image must be converted to digital form. Otherwise, we cannot process it. So image digitization refers to the purpose of sampling and quantization of the analog signal, which is required to convert the analog signal to digital form. So we need two methods. One is sampling and is quantization for the digitization of image. The digital process image processing is performed using digitizers, and digitization process consists of two steps. One is sampling and other is quantization. So sampling and quantization are two important steps for converting an analog signal into a digital one. Let us discuss more about sampling and digitization, how these two processes are used to for this purpose. Sampling refers to considering the image only at a finite number of points. Each image sample is called a pixel. Sampling refers to considering the image only at finite number of points. So sampling means considering the image only the finite number of points. That is where the location of that point. Where the location point. As you know, uh, digital image is a two-dimensional values. It contains two important values. One is the location xy and its value f of xy. Similarly, the quantization refer to the representation of the gray level value at the sampling point using finite number of bits. For example, 256 label quantization result in an image of 8-bit pixel as we discussed. An image consists of 256 different type of values, gray level values, which ranges from 0 to 255. We have more example with sampling and quantization. When we capture the image of an object, we use image sensor to sense the incoming light and form the image. So image sensor convert the incoming light from the object into electrical signal that can be stored and viewed later. These analog signal are continuous. The image are stored in a analog form. So this is the analog image, but it needs to be converted into digital form. So that we cannot process analog image by a computer. So analog signal contain infinite points and we need infinite memory to store them. So that is why, as you know, that analog signal contains more infinite points and we have large memory. So we need to convert the analog image into digital image to store and process by a computer. So that is why it needs some digitalization there. An analog image must be converted to digital image by digitaling the analog signal. We apply sampling and quantization to the analog signal to convert them into digital form. Let us take some example how a digital analog image can be converted to digital form. A digital image is formed by arranging pixel in rows and column. We know that every uh, pixels have a location and a value, and each pixel is formed by arranging the pixel in the rows and column in a matrix form. You may recall that image contains some image of that skeleton which is form some values which are form a matrix form. So rows and some columns are there. So each pixel has a particular integral value. It cannot be fractions. The image value is an integers, ranges from 0 to 255 here. The computer processes that integral value and shows that pixels. The arrangement of the pixel from the digital image. You see here. To create a digital image, we need to convert continuous sense data into digital form. So as you know, there are two steps process. One is sampling, which digitize the coordinate value called sampling. So sampling is associated with the coordinate values, the location of the pixel. And quantization is amplitude value or gray level values of that pixel. So sampling is associated with the location, where the quantization is associated with the intensity value, gray level value. To convert a continuous image fxy into digital form, we have to sample the function in both coordinates and amplitude there. You see here, there is an analog signal. Some sampling function is used to find the different location. One minute. Okay, so
Hello, good morning, sir.
uh, yes.
Sir, can we get the recording of this lecture after
Uh,
the?
Actually, I don't have the recorded data. But I think it is available in the Merit website.
But actually, sir, some lectures are missing there, so that's why I'm asking for the confirmation that we.
Uh, Basically, I don't have any that is anything that is any data recording. That is, they are recording. If you request them, so they may provide you.
Okay, okay. Thank you, sir.
Yes, yes. I got some question in a board. You will get some answer that is what is quantization error or something in the latter slide, and also you will get some answer that is there are some slides which contains that question there are some question. We'll discuss about that in the question answer uh, session. I think there are some questions which are already there in my later slides. So once the image is sampled, that is its location is sampled. After sampling the analog signal, uh, we may apply quantization, and quantization is, as you know, it is associated with the gray label values of that particular picture image. So the quantization derives the amplitude of the sample signal. Quantization is done by the rounding of the amplitude of each sample and then assigned to a different value according to the amplitude. Each value will represent a different color tone. Let us see. So one analog signal, when it is sampling, you see after sampling it uh, gets its location. So sampling is associated with the location, the XY value of a pixel. But still it is not digitalized. It is not converted to a digital signal. It needs, after sampling, it needs quantization. And after quantization method use, so as the quantization is associated with the gray label values, once it uh, gets the location, then it finds its gray label values, and now it is converted to a digital signal after digitalization. And if you compare the sampling and quantization, it determines the number of pixels of a digital image because they are associated with the pixels, location of the pixels. But in other hand, quantization determines the tone of the pixels, that is the gray label value of the pixels, the intensity value of the pixels. Sampling digitalization the x-axis of an analog signal, while the quantization digitalizes the y-axis of the analog signal. As you know, uh, uh, it is a two-dimensional. So sampling is a in x-axis, and quantization, the gray label values, is in y-axis, represented in y-axis. The amplitude value of the analog signal is recorded at a regular time interval. The amplitude value are rounded of the given value. If you get some pixel, it is rounded to get a nearest integer. So done prior to quantization, and basically the quantization is performed after sampling. Once the sampling is done, the quantization is take place. There is another term, pixelation error. You may get the question in the exam. Write a short note on pixelation error, or what is pixelation error. You may get some numeric question. You see here, the size of the pixel is important for image quality. If the size is very large, there will be lesser number of pixels, because you know that your the computer screen or the screen is constant. You cannot increase or decrease the size of a screen. So but the image, the size of a pixel may vary. If the size is very large, so there will be lesser number of pixel. If the size is less, there will be larger number of pixel in the size. So there will be lesser number of pixel. Hence, the details become less, which makes the image distraction and meaningless. That is, the quality is degraded. This is called pixelation error. Where the gray label discontinues at the edges of pixel become poor. So as the size of the screen is fixed, if the pixel size is more, the screen contains less number of pixels. If an image contains less number of less number of pixels, is quality is degraded. So my question is here, what is the usual size, what is the ideal size of a pixel so that the image quality will be better. Let us see. Yes, same question is asked here. The question is that what should be the ideal size of the pixel? Should it be big or small? How do you consider? That is, what is the ideal size of an pixel so that it gives a better quality, good quality. You see. So the answer is given by the Shannon-Nyquist theorem. According to this theorem, the sampling frequency should be greater than or equal to 2 into f max, where f max is the highest frequency present in the image. Okay, so it is highest frequency in the pixel image. As you know, the pixel contains different type of gate level values. F max is the highest value. F max is the highest value. Otherwise, the original signal cannot be reconstructed. Let us see. We have a question, and I think this question, exactly this question, uh, 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 once come in your previous exam. What should be the physical size of a 2D image of a document with dimensional 2400 and 2400 pixels resolution, that is, when scanned into 300 dpi, here dpi stands for dots per pixel. So what should be the physical size of the 2D image so that it has a good quality? The physical size of an image is denoted by, that is, it is calculated as number of pixel in width by resolution into number of pixel by height into resolution by resolution. For example, here is a 2400 by 300 into 2400 300 by 300, 8 inch into 8 inch. So that means the physical size of the two image must be 8 inch into 8 inch. Okay. There is another additional question is there. If the physical size of a medical image is 8 inch 8 inch and the sampling resolution is 5 cycle per mm, then how many pixel per cycle are required to have better quality image? Will an image size 256 into 256 be enough? Let us see the previous question once again. Uh, the physical size of an image, and it is calculated as number of pixel in width divided by resolution into number of pixel in height by resolution. So as 2400 is the width and 2400 the same as height, so by 300, this is also divided into 2400 by 300, 8 inch and 8 inch. So answer of this question is 8 inch to 8 inch. That means the physical size of 2D image document of dimension must be 8 inch and 8 inch. If the physical size of image, you see there is another question, additional question, you see, if the physical size of the medical image is 8 into 8 inch and the sampling resolution is 5 cycle per mm, then how many pixel per cycle are required to have a better quality image? Okay, you see, it is given that the sampling resolution 5 cycle per mm. Therefore, for better quality, 2 pixel per cycle are required. This is because theorem sampling theorem states that the sampling frequency should be greater than twice the maximum signal frequency. So that means that 10 pixel per mm are required. So the pixel size is 0.11 mm. It is note here that the double rate in both directions as called Nyquist rates. Thus, given image is, since we know that the values of 1 inch is 2.54 centimeter. So 8 into 2.54 into 8 into 25 centimeter, that is 20.32 to 20.32 square centimeter. And there's an additional question you see, it is written in previous one, will, you see, will an image of size 256 into 256 be enough? Will an image of size 256 into 256 be enough? Therefore, the minimum number of required pixel is 2032. It is square centimeter. So 2032 into 2032 pixels. So an image of size 256 into 256 is not enough because we minimum required 2032 and 2032. So 256 size is not enough. There are some sounds. Then image resolution. It describes the image level of details. High resolution means more image details. In digital image, the resolution is often measured as pixel count. A pixel is a single point or a tennis square in a graphic image stored in an order rectangular grid. So the number of pixels present in a unit square, in a one unit square of a screen is known as its resolution. So it is the smallest element in digital image. You know that a pixel is considered the smallest element. It cannot be further divided. Like your a point in a geometry, that is, you know that a line is a combination of some points. So a pixel in a digital image is known as the smallest unit. The resolution pixel count measurement is a quantified for a specific unit or length. So the unit of usually an inch, and the measurement is called pixel per inch PPI, and sometimes it is a term as DPI. So uh, dots per inch. So uh, although DPI more accurately refer to the resolution of the printing image. So you may consider that is the have an image having more resolution is uh, more clear, as having a good quality. You see 72 DPI as compared to 200 DPI as compared to 600 DPI. So the last picture, which is the 600 DPI, have a best quality among the three. Then the after resolution, the second character is intensity. The term intensity refers to the amount of light or the numerical value of the pixel. So as you know in previous slides, that is this value, intensity value is ranges from 0 to 255 in a 8-bit gray level values. It is ranges from 0 to 255. So it is a numerical value. It doesn't contain fraction. You cannot tell the intensity value is 2.5. It is an integer value which ranges from 0 to 255. It is measure the energy of the wave, which is directly proportional to the square of the amplitude of the signal. From the point of the view, image processing, it is a numerical value which represents a pixel. For example, for an 8-bit grayscale image, the value of a pixel can be in the range 0 to 255, where 0 represents the black color and the numeric value 255 represents the white color. So a pixel having image value 200 is more brighter than the intensity value, the pixel having intensity value 100. 100 is deeper or darker than the pixel whose value is 200, because 200 is nearest to 255 and 100 is nearest to 0. So that is why the pixel value which are the value intensity value 100 is darker than the pixel value 200. You see, so the higher value of a pixel is whiter. The pixel which appear in grayscale image, intensity is depicted by the gray label value at each label. 2 pixel with gray label value 127 and 220. So which one is the darker, which one is the brighter? The 220 is nearest to 255, so obviously it is brighter. 127 is lesser than 220, so that is why it is darker. So then it can be interpreted that pixel with value 127 is darker than the pixel with the value 220, because 220 is nearer to 255. So that is why it is more darker, because 255, sorry, more brighter. That is 250 is white color. So 220 is more brighter, where 127 is less than 220, so it is more darker. So besides these two, the another term is constant. The term constant of an image relates to the recording of the difference in the amplitude, sorry, in the magnitude of the intensity at the surface of an object. There are many ways in which constant can be measured. It can be described as the product of the sensor signal constant, energy source and the physical property of the object, and detector constant. This depends on the way signal is detected, captures or stored. So this is a, you heard about the component or uh, of the constant resolutions, intensity. It refers to average pixel intensity of the image, average pixel intensity. So you know that the different pixel have a different intensity, and basically the brightness is the average pixel. You take the average value, and you can term as a brightness of the image. Similar to constant, the image should be reasonably bright to show all the information to the viewer. Reasonably, if it is more brighter, it may be not viewed by the viewer. So it is a reasonable bright. Should the excessive brightness may affect the quality of the image. Similarly, an image may have a higher brightness, but if the intensity is not optimal, the image again will not exhibit good quality. Okay, so image higher brightness, but the intensity is not optimal. Okay, so the image will not exhibit good quality. Similarly, the brightness resolution is defined as the number of identified distinct color, and it is also called as color resolution. Noise, which we don't want in our image. It is an unwanted disturbance that causes fluctuation in pixel value. Some pixel value is spurious, some is missing. So that is the term as a noise. It is a random or stochastic process that hence it is a true value cannot be predicted accurately. Basically, true value cannot be predicted. We don't expect a noise in our image. However, noise obeys all the statistical property. So when you take an image, suppose your image moves or your hand moves when capturing the picture, your camera moves. So you will get a picture having some image. So that is the unwanted disturbance, the unwanted component where the image has. We'll discuss more about the noise, what is the type of noise, what are the process to remove a noise, because we don't want the noise to be present in our image. It should be removed. So there are some process how to remove the noise. Okay, so we'll discuss about more what are the types of noise. There are the different type of noise and what are the techniques to remove the noise. In lateral sides in your lateral block, there are in your course that is there. So we'll discuss about that the lateral slide. We know an image is associated with the signal. Any physical phenomenon that conveys or carries some information can be called signal. As you know the definition of signal, the signal is anything that we can see, hear, observe, or measure using some machine. For example, speech. Speech is also a signal. Audio signal, you know the audio signal. Light signal are there, radio signal are there, TV are there, the radar, your temperature signal are there, ECG, EEG. So all are the signal. All are the form of the signal, different signal. So it is nothing but it is a physical phenomenon which convert or carries some information can be called signal. Your ECG report of a patient, it is represent that how your heart works. So from that signal, the doctor will check that uh, what is the status of the your heart, how it works. Usually, the information carried by a signal will be function or one independent variable. So the signal contains some information. All the signal contains some information. Uh, the independent variable can be time or spatial coordinate, intensity of color, pressure, temperature, etc. So the information carried by the signal will be a function of an independent variable, and that independent variable may be this. But basically, the most popular independent variable is the signal time and depend by t. So depending upon the depend upon variable, that is one dimensional signal or multi-dimensional. A signal which is function or single independent variable is called one dimensional value. That is music, speech, heartbeat. There are only one dimensional value. But our image is two dimensional value. Or image is two dimensional value we have already discussed. It is the location, the xy and f of xy. A signal which is a function of two or more independent value is called the multi-dimensional value. A photograph is an example of two-dimensional signal. As we discussed, the image is a two-dimensional signal. The motion picture of a black and white TV is an example of a three-dimensional location and also sound. Say your as we discussed, the one-dimensional signal is a function of a single variable. A one-dimensional continuous signal is represented as a function ft of the independent variable t, representing the evolution of physical phenomenon across the time t. For example, a 1D audio signal such as the electrical signal and the output of a microphone is the function of the time. But we are associated with the two-dimensional signal, our image. That is a two-dimensional. You see, a 2D signal, xy and f of xy is a function of two independent variables x and y, such that xy indicate the point of a 2D space, its location. For example, if the function f shows the intensity of a still image, then f of xy represents the value of the intensity of the pixel at that location. So, a photograph, a still image, is a two-dimensional signal. So, the summary of the signal is a photograph, a still image, is a two-dimensional signal. Same thing. We will discuss image as a 2D signal. A, an image or a grayscale image is a discrete 2D signal if f is having two independent variables x and y, so that fxy is the value of the signal at pixel, huge location, and image given by the integer x and y. The 2D signal can be of various types such as separable, periodic, etc. Therefore, the 2D signal represents the digital image where the xy the location and pixel. So we have already discussed about. No need to discuss again. And we know that a 2D a digital image is consist of two things. It is a two-dimensional signal. One is your xy, the location. Another, the value of that pixel at that location xy, which is depended by f of xy. So intensity value or gray level value. Transformation. What do the word transformation mean? Transform means that is transforming, converting one form to another. Anything. Converting one thing to another is known as transformation. So we need to transform from a signal to a 2D or image to a 2D signal. Image transform are necessary for image analysis and image processing. Transformation are mathematical functions that allow us to convert from one domain to another. So transformation need sometimes that is we need one thing to in another form because some operation is not suitable at that form. So we need to convert to another form. Once it is converted to another form, that operation will be easy. So that is why we need transformation. So transformation of signal fx will convert the signal into a new signal, say gy, in a different domain. However, transformation does not change the information content present in the signal. So transformation means only it converted to one form to another form. It does not mean that the information is lost. There will be no loss of any information. There no change in information contained in the picture. If the information changes, there will be no need of transformation. That is, if you transform from when you transform from a image from one form to another form, we found that some information is lost. So at that case, the transformation is not required, is not suitable. We do not want the transformation if the information lost. So transformation means we transform from one form, one domain to another domain, and provided that there will be no loss of any information within the image. Let us see. There are some example of transformation. It may not be related to our image. You see, if you multiply x double I into x, suppose you are given a question, multiply x double I, that is a Roman form. You know that this is value of 12 and x stands for 10. Unless you transform to our general numeric format, we cannot multiply it. So first, it need to transform. We know that x double I into x double I stands for 12 and x double for 10. So now it is easily multiplied. That is, the multiplication operation cannot be performed in Roman form. You cannot multiply that. X double I, X, there is no multiplication process. How the X is multiplied to 1, why X double I, you cannot multiply. So that is the need of transformation. Okay. So multiplication operation cannot be performed here in when the number is dependent in Roman form. So that must be converted to our usual numeric form. So we know that X double is 10 and we multiplied 12 into 10. So easily it can be calculated to 120. So it is a transform. You see in the second example, 12,000 into 1,500, long integer form. So if a integer is very long form, if you multiply them, you take more time. And besides that, it also require more space to store. So that is why you can convert to it. It's a exponent form. That is your you remember your floating point representation form. Floating point representation. 16-bit representation, 32-bit representation with a mantissa with an exponent form. So in a floating point can be represented in a mantissa and exponent form. There are different methods to represent that. So what are the benefit? Why do you transform? To perform any operation in a long integer. Suppose it's 1 lakh something. 1,57,000 725 into the same value. So it takes more time if the integer is very large. But when you convert to a floating point form or a polynomial form is given, you see now it is easy to perform any operation because the exponent are same. You multiply them, and if the exponent are same, you add them and find the result. Okay. So these are the need of the transformation. Similarly, in the same way, an image may not be suitable for a particular operation in one domain, in one form, but you want to perform that operation. But the present form of that operation, the present domain of that image is not suitable for that operation. So to perform that operation, you need to transform your image to another form. Once it is converted, then you perform the operation, then you may come back to the original format. So these are the transformation. This is the need of the transformation. So you please write your name and registration number in the board for the attendance. Those who have don't written, so please write here. If you have written, no need to write again. Let us take a snapshot. Please wait, don't leave. I will discuss the image profile and from this slide in the next class.
Yes, sir.
Okay. So, though, have all of you completed the projects, or they are written synopsis, or what is the state? Can you write it on the chat box? Those who have not written the synopsis or project so far, you know which is most viral today is AI and big data. These are the two things on which you should devote yourself for writing the projects, synopsis and projects and all that. I think that's the best way because that will help you in the interviews and also help you for growth. You can soon become the entrepreneur yourself, and rather than getting job somewhere, you can be giving job to some people. AI based, good. Abesh Khan. Just give me your heading of the project again. Abesh,
Yes, sir.
based phishing detection system. Okay, good. That's uh, that's also good. AI based fraud system. AI based converting mail from mail to spam. All these are important things. Now, you should not. My suggestion for you is you should not cheat in writing project. You should write the project yourself. If you are taking software from somebody or you are taking some write up from somebody, please acknowledge that. And your thesis should be about 100 pages, 150 pages with all your coding and all that. Don't make 300 pages, 400 pages copying something that all that. So that's important. Then AI एआई में अगर आप डीप लर्निंग कर रहे हो न्यूरल नेट कर रहे हो या मशीन लर्निंग कर रहे हो you should be very clear that what you are working on it and you should know about it and that's what is going to help you in future also because neural net is important so is also important Bayesian algorithm is important so is also important machine learning is important you, deep learning is important expert system is important. So that's where you should depend, you should work on all these things. Now, anybody has a question on person who has not written synopsis still, please write a synopsis which is AI based. Abesh, it's okay. I find your project is fine. You should be working on phishing, and phishing is made. AI is very important, so that's good. Because cybersecurity and AI are again netting each other. That's very important. And the fraud happening. So somebody is spending 10 rupees or 1000 rupees and suddenly he starts spending lakhs of rupees. That is again a fraud, which is probably the bank should inform the person that you are spending this. Are you sure you are the person or somebody else is doing it? So that again is important thing. So that's Mukul. Yeah, Mukul, I'll write your project name. Anybody wants to discuss on the synopsis? Shakti Swarup, Swarupa, Sabrupa, yes. Mukul Singh, AI driven personalized diet and fitness assistant. Good. It's all right. Good, good, good. But only diet should not be considered. How about exercise? And if you are only considering diet, that should not help. It's also exercise that should come through AI. Now, AI, you can generate the AI to do a lot of things for you. And that's also what type of exercise you should be able to do it. Because exercise is also important for making you fit. Shakti, what have you written? Shruti, Amita, write down please. I can't see the other names. Prachi, there are 18 others. I can't see the name. Abdullah Khan, Shivani Pal, Shruti. Now, what project you have written, Shruti?
Text summarization tool using NLP.
Eh?
Text summarization tool using NLP.
Using what?
NLP, natural language processing.
You are using AI, not?
Yeah, that is a part of AI, using AI models.
Okay, good. You have written
It
the
will
project
summarize the
already?
text.
You have already completed the project?
No, it's in progress. Synopsis I have submitted.
Topic has been approved?
Yes.
Okay, good.
Thank you,
Good.
sir.
Go ahead. Shakti, Prachi, Amida, Parveen. Prachi, come out with any suggestion which you want. You want help? You should base your project basically
सर
on
आवाज
AI.
सुनाई नहीं दे रहा है.
Yes.
आवाज नहीं आ रही है.
आवाज नहीं आ रही?
हाँ.
Okay. Now, are you able to hear me?
Yes, sir, you are audible.
Are you able to hear me now?
Yeah,
हाँ.
sir, you are audible.
Okay. सुविधा आपको?
वो वॉल्यूम थोड़ा कम आ रहा है, सुनाई दे रहा है.
Okay. आप किस पर प्रोजेक्ट लिख रहे हो?
एक मिनट. हाँ, मैंने एक मिनिट. हाँ सर. प्रोजेक्ट माझा
आपने सिनॉप्सिस लिखा है? अरे बताओ भाई. फमीदा परवीन, अब्दुल्ला खान, CD. If you want to submit your project online, then you have to. I think you should ask Tushar. I'll tell him to report it to you. Okay.
Sorry, sir, to whom I should ask?
Tushar. All right. Just hold on. You have to read the question. I will raise it to Tushar.
Sir, you are not audible.
Just write down the question again. तुषार, ये सीडी का प्रोजेक्ट में देने की जरूरत होती है? So, everyday Shruti, why they want CD? Sometimes they want to run it and show it. So they say, please send the CD also.
So instead of CD, can I give a GitHub link and show them like running in the front of them only?
तो वो तो तुम दिखाओगी ना, अगर वो रन करके दिखना चाहें तो।
लाइक GitHub लिंक से मैं रन करके दिखा सकती हूँ
ओके
अगर
ओके, so that you can talk to RC when you are submitting. Who is your guide?
guide, external guide, like not from IGNU.
Huh?
External guide, not from IGNU.
ओके, तो एक्सटर्नल गाइड कौन है?
लाइक सर किसी को भी चूज कर सकते थे जिनका लाइक पोस्ट ग्रेजुएशन हो चुका हो, प्रोजेक्ट एक्सपीरियंस हो, और तो मैंने अपने
use anybody,
रिलेशन में
who
लाइक
can who can guide you. And then synopsis में तुमने गाइड नहीं लिखा था क्या?
लिखा था सर.
हाँ, तो उसी को गाइड आपने फाइनल प्रोजेक्ट में ही बनाओ.
ओके. ओके सर.
ऑलराइट, वेरी गुड. सुविधा, आप कुछ कह रही थी?
हाँ, होममेड रेसिपी रिकमेंडेशन सिस्टम इस पे बनाया है.
आपने सिनॉप्सिस दे दिया है? As
हाँ
it-
हाँ, सिनॉप्सिस अप्रूवल होके आ गया और
ओके,
प्रोजेक्ट भी सबमिट कर दिया है.
प्रोजेक्ट भी सबमिट कर दिया है.
हाँ,
गुड.
मेरा ओडीएल है.
है?
ओडीएल है.
ODL है. ओके,
हाँ,
फाइन फाइन फाइन. तो प्रोजेक्ट का नाम क्या है?
प्रोजेक्ट का नाम है होममेड रेसिपी रिकमेंडेशन सिस्टम.
ये बड़ा रूटीन लगाया तुम. चलो ठीक है, अब दे दिया है तो ठीक है. उसमें कोई AI वगैरह लगाना चाहिए था, जब
हाँ, एआई लगाया है.
लगाया है तो उसमें नाम भी, हेडिंग के नाम में भी AI लगाना चाहिए.
हाँ.
ओके, सो दैट मेक्स इट मॉडर्न.
हाँ.
दैट्स इम्पोर्टेंट. गुड. ओके, गुड. प्राची, anybody else wants to talk about the project?
Yeah. Hello, sir.
Yes.
Yeah, sir. I have created online academic management system using Java programming language.
Okay, so you have already submitted the project?
Yeah, sir. I have already submitted
Okay,
in
fine.
my regional center.
Okay, fine. All the
Yes.
best. Good. आपको जब जब वायो वसा होगा, then you should be able to see that what you have written, you should be able to answer that question very clearly.
Okay, sir. Should I represent code as well, or only they ask theory questions related to project?
They will ask why did you select this project and what are the importance of this project, okay, and
Okay.
what is the future of this project. These are the
Okay.
fundamental questions on which every project will be asked.
Okay, sir. Can I run project also to represent them how it's works?
Yeah, why did you take this project, and how did you work it out? How did you use Java language and all these things and all that? Why not Python? Why other language you have not used? So that's the type of questions which can be generally be asked and all that.
Okay, sir.
Yeah.
Okay. Sir, it's online or in a regional center.
Online.
Project Viva is going on online or in my regional center.
You have submitted online or offline?
No. I asked, should I attend my Viva on online or should I go to my regional center to attend Viva?
Okay, it will be online.
Okay, sir. Okay,
Okay.
sir. Okay, sir.
Prachi, Famida, Other people, anybody else has a question?
Excuse me, sir.
Yes.
So when will we have our Viva?
Say it again.
So when will we have a Viva, sir?
Viva should be sometime it takes about a month from when your project is submitted. So between 1 and 2, it is Viva is there.
Okay. Okay, sir.
Okay.
Fine.
Prachi,
I worked on RAD system, sir,
Yes, sir.
actually.
प्राची आपने प्रोजेक्ट सबमिट कर दिया?
सर एक्चुअली आई एम वर्किंग ऑन इट सर. मेरा अभी प्रोजेक्ट मैं अभी इस पे कोड पे काम कर रही हूँ एंड देन फिर आई विल जस्ट प्रिपेयर विद द रिपोर्ट एंड आई विल सबमिट इट सर.
And your synopsis has been approved?
Yes sir, synopsis is approved.
Okay. You are using AI in your project?
Yes sir, मेरा प्रोजेक्ट है AI बेस्ड फिशिंग डिटेक्शन सिस्टम सर.
Very good.
जी वहाँ
Very
पे
good.
मैं मशीन लर्निंग टेक्निक्स को यूज कर रही हूँ सर. डिसीजन ट्री मेथड्स एंड रिग्रेशन सारी चीजें यूज कर रही हूँ सर.
Good. Good.
थैंक यू सो मच सर.
All the best.
थैंक यू सो मच सर.
Okay. Famida? Famida, Praveen is not speaking. He just put it on Abdullah Beshka. Or कौन है? Or anybody else out of the 18 others? Anybody has a project or any question? आप लोगों ने तो बुकलेट तो पढ़ी होगी जो इग्नो की है ऑन प्रोजेक्ट्स.
Yes sir, the guidelines we are following sir. Like I am following the guidelines.
Say it again.
Yes sir, the IGNU guidelines for the project submission sir. MCSP232. Yes, I am following this sir.
Okay. Okay.
Yes, thank you.
Any other person? Question? There are 18 other people whose name I can't see. Can somebody raise the question, ask for question?
So regarding the project, I did not get any email from them. I just went to my LMS portal, and there I saw that it has been approved. That my project has been approved. So what should I do regarding that, sir?
Project has been approved, they have written?
Yeah, yes, sir. I downloaded a PDF, and there it was like your project has been approved.
Very good. So you are lucky. Without Vibe also your project has been approved.
I mean, sorry, not the project synopsis I was talking
Oh,
about.
synopsis. Okay, that's okay.
Yeah.
That's
So,
okay. That's okay.
so is it okay if I don't get the email also?
That's okay. Once they have said it is approved, it is approved.
But in the remarks, they have added that I have to add something unique in this. So,
There may be also remarks which you have to include it in your final project.
okay. So is it normal, sir? Like it's not an issue, right? It's normal.
Yeah. It's synopsis is approved, that's final. And if there are certain remarks in the synopsis, those should be included into your project also.
Okay, fine. Good.
Okay. All the best.
Thank you.
Yes. Anybody?
Yes, sir. Good morning, sir.
Huh.
So, I wanted to ask that if our synopsis is approved and we did not receive the copy when we were receiving the receipt, do we need to go and bring that synopsis only to attach with the project?
No. Synopsis have been approved.
Yes, yes, sir.
You should have a copy of that. And that should be put part of the project also.
Okay,
The
sir.
approval letter should come as part of the project report also. right?
Yes, sir.
Okay.
Thank you, sir.
Now, Famida, Famida Parveen. बोलो भाई. Anybody else?
हेलो
हाँ पूनम.
गुड मॉर्निंग सर
हाँ.
सर एक्चुअली मेरा क्वेश्चन ये है कि मैं थर्ड सेमेस्टर में मैंने सिनॉप्सिस डाला था और अब वो अप्रूव होके मुझे मिल गया था बट सम रीज़न मैं प्रोजेक्ट सबमिट नहीं कर पाई थी और रजिस्ट्रेशन नहीं हो पाया था मेरा प्रोजेक्ट का तो आरसी से उन्होंने बोला था कि जब तक आप रजिस्टर नहीं करोगे आप प्रोजेक्ट सबमिट नहीं कर सकते
ओके.
तो उन्होंने मुझे नेक्स्ट सेम में बोला था रजिस्टर करने को मीन्स जैन जैन में 2026 में
हम्म.
बट अभी के लिए मुझे ये कंफर्म नहीं हो रहा है कि लास्ट डेट क्या है उसकी प्रोजेक्ट सबमिशन की और मेरे सिनॉप्सिस पे ये
ठीक
अप्रूव
है.
तो लिखा हुआ था बट उस पे सम लाइंस लिखी हुई थी कि आप कुछ मॉड्यूल को थोड़ा सा अपग्रेड कर दो
नहीं, सिनॉप्सिस अप्रूव था कि नहीं अप्रूव था?
सर अप्रूव्ड है बट उसमें एक लाइन लिखी थी कि मतलब आपकी एक मॉड्यूल था कि इसको थोड़ा सा आप अपग्रेड कर सकते हो और
ठीक है.
डिटेल में
ठीक है, जो सिनॉप्सिस अप्रूव्ड हो उसको लगा दीजिए और जो अपग्रेड करना है वो प्रोजेक्ट में करिए.
तो सेम सिनॉप्सिस जो पिछली बार अप्रूव हुआ है वही प्रोजेक्ट रिपोर्ट में लगेगा ना
That's it. That has to be put in the project also.
ओके 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 तो सर इससे कोई इशू तो नहीं होगा कि मैंने पिछले सेम में सिनॉप्सिस अप्रूव किया और मैं इस सेम में प्रोजेक्ट रिपोर्ट सबमिट करूं
नहीं, कोई बात नहीं है. You can give the reasons that why delay has been done and all.
या सर सम पर्सनल रीजन द लास्ट डेट वाज मिस बाय मी
Yeah. Registration नहीं हुआ था, ये all these things you can write.
ओके ओके सर थैंक यू सर
All the best. Anybody else? There are 21 people more. Anybody from 21? Yes? We'll be meeting tomorrow also, but आज जिन जिन का कोई questions है, let's raise the question please. Hello? No questions?
नो
I
सर
देखो बेटे, एक चीज है कि जो भी प्रोजेक्ट बनाओ, मेक इट वेरी नीट एंड क्लीन विदाउट एनी चीटिंग, और make the project which is amenable for your interviews and for your future, because that project, MCA project, becomes the Bible for your future whole work. And if you are using somebody else's program, please say that. If you are using somebody else's write-up for somewhere, please say that, so that you acknowledge that. So that's important. And whatever you write yourself in your own words, so that you are very clear what you have written. You should be very objective in what to write. नो कॉपीइंग, नो चीटिंग. अगर कॉपी कहीं से करते हो तो बताओ कहाँ से कॉपी करा है और उसको एक्नॉलेजमेंट करो. So that's the most important part of your culture, so that your project should be neat and clean. Your project, you can claim that that's only your project, nobody else's project. You are not copied from somebody else. That's important. Okay. You put your name and enrollment number on your chat box, please, so that I can take the attendance.
क्लास आपका हो गया?
अभी चल रहा है, उनको बोलो कि अटेंडेंस ले ले।
ठीक है। अंकिता है, अंकिता मिलना चाहती है।
आ जाओ, आ जाओ।
भेज दो ना।
हाँ।
भेज देता हूँ।
उसको
बेटा भी है।
हाँ, और उसको रहीम को कह दो जरा
अटेंडेंस और भी है।
हाँ, आओ इधर। हमारे जैसे पतला है में।
नहीं सर, मैं तो बहुत मोटी हो गई हूँ, तो वैसे ही इसका अंडर वेट ही रहता है। अंश फैट शो सर।
मैं इसको खाने को देता हूँ कुछ।
इसको सब ब्लेसिंग्स दो आप पहले।
ऑल द बेस्ट बेटे। पढ़ो, अच्छे अच्छे पढ़ो। ये मामा को
What should we say?
कौन सी क्लास में पढ़ता है?
बताओ।
थर्ड में? अरे बाप, तो बड़े हो गए हो।
इधर बैठो, आप उधर बैठो सोफे पे। गो एंड सिट देयर। ये दोनों आप।
ये तुम्हारे लिए।
अच्छा, मैं कोई। और बताइए सर, कैसे हैं आप? तबीयत कैसी है आपकी?
बिल्कुल।
आप तो अच्छे लग रहे हो, फिट लग रहे हो, फिट लग रहे हो। पिछली बार थोड़ा बीमार से लग रहे थे जब मैं मिली थी आपसे।
मैं बात तो कभी भी नहीं हुआ।
नहीं, थोड़ा लग रहा था, लो लग रहे थे, हमेशा थके हुए थे।
आज तो मैं 2 घंटे बोलता रहा हूँ।
हाँ, नहीं आज तो बिल्कुल फिट एंड फाइन, टच वो लग रहे हो, मतलब फिट लग। आप लगते नहीं हो ना 90 के, आप बिल्कुल नहीं लगते।
But you are looking fine.
हाँ सर।
लेकिन पतली हो गई
सर, अभी तो होना है, मेरा वेट तो बहुत बढ़ गया है।
और पतली होना है?
हाँ नहीं सर, बहुत बढ़ गया वेट मेरा।
40 नहीं हो तो ठीक है।
और बताइए सर।
उसका मुंह भी तुम्हारे जैसा है उसका।
ये तो अंडरवेट है, तो डॉक्टर कहते हैं कार्ब्स खिलाओ थोड़े। अंडरवेट है ये।
क्या खिलाओ?
कार्ब्स खिलाओ, कार्बोहाइड्रेट्स।
हाँ, I was also always underweight. So
अच्छा ठीक है सर।
मैंने जब 10th क्लास करी तो मेरा कद 4 feet 8 inches।
अच्छा।
Then I went to college. I became 5 feet 8 inches.
नहीं, अभी तो आपका सही है, हाइट तो ठीक है
अभी। That's why I say 4 feet 8 inches से 5 feet 8
सीधा एकदम
inches।
से बढ़ गया। ठीक है, हो गया।
ओ,
सभी में आ रहा है ये। टेस्ट मैसेज भेजा है गवर्नमेंट ऑफ इंडिया ने।
India launches self-broadcast using indigenous technology for alerting service for alert citizen safe nation. No action is required by public upon receipt of this message. This is a test message government. ये तो good.
मुझे भी यही आया सेम।
Good.
सभी को आया है।
सबको। That's good. You, the Home Minister or information वो जो टेक्नोलॉजी
अंश
ब्रिज
नो मत करो,
बैठे इनको नहीं करने दो।
सर ये बहुत शैतानी कर रहा था वहाँ पे।
तो वो उसने आज करना था। So this is their given.
हाँ
So we don't have to do anything. They have
हाँ
done.
दे आर जस्ट टेस्टिंग द
Yeah,
मिक्सर।
good.
नहीं अच्छा है, इनका एक साथ सभी कोई आया ना, सही है, बढ़िया।
अच्छा तो तुम्हारा कोर्स वर्क तो बहुत पहले कंप्लीट हो गया था।
हाँ सर मेरे ना मैंने 3 पेपर भेजे थे वहाँ कॉन्फ्रेंस में ना, तो 3 पेपर भेजे थे कॉन्फ्रेंस में, लेकिन वो रिजेक्ट हो गए। तो अभी मैं दोबारा, एक्चुअली मेरा टॉपिक ना थोड़ा डिफरेंट है, वो मेरी सुपरवाइजर को भी अपना मतलब इतना उसमें वो नहीं है, वो तो मेरे को खुद ही करना पड़ रहा है सारा।
क्या
मेरा एक्सप्लेनेबल एआई है, एक्सप्लेनेबल आर्टिफिशियल इंटेलिजेंस, एक्सप्लेनेबल आर्टिफिशियल इंटेलिजेंस।
व्हाट इज एक्सप्लेनेबल?
अंश
नहीं करने दो,
मत करो ऐसे नहीं, गलत बात। आप आपने आज प्रॉमिस किया
अच्छा
था,
इसको
आप
मैं
कर
कुछ
दिया।
दूं लिखने को?
ये वहाँ पे भी शैतानी कर, नहीं कोई नहीं सर, ये लो फोन लो।
इसको खोल के दो, इसको दो खोल के दो खाने को।
ये अभी को मना कर रहा है, मैं दे दूँ सर, कोई नहीं, अभी सेट हो गया।
अच्छा
तो अच्छा ठीक है, एक्सप्लेनेबल एआई है मेरा। जैसे हम आर्टिफिशियल इंटेलिजेंस यूज करते हैं, ठीक है, मेरा डेंटल में है प्रोजेक्ट, तो आर्टिफिशियल इंटेलिजेंस यूज करते हैं उसमें। तो आर्टिफिशियल इंटेलिजेंस को जैसे अब जो हमारे डेंटिस्ट होते हैं उनको कैसे पता लगेगा कि आर्टिफिशियल इंटेलिजेंस से सही वो निकाला है कि नहीं निकाला, तो उस चीज को एक्सप्लेन करना, दैट इज एक्सप्लेनेबल। मतलब उस आर्टिफिशियल इंटेलिजेंस ने कौन सा फीचर यूज करके इसका रिजल्ट निकाला है कि कैट है या डॉग है, तो वो चीज में मैं काम कर रही हूँ।
व्हाई डिड यू टेक दिस प्रोजेक्ट?
सर ये डेंटल में ना सबसे बड़ा लिमिटेशन था, और ये थोड़ा अंडर एक्सप्लोर्ड है अभी डेंटल में, सो दैट्स व्हाई आर्टिफिशियल इंटेलिजेंस पे।
ओके। और कौन सा पेपर करने हैं? एक ही पेपर करोगे?
नहीं, अभी तो मैंने 3 पेपर भेजे थे कॉन्फ्रेंस में।
और कौन सा भेजेगा?
यही था, इसी पे मतलब इसी पे वैरायटीज थी। तो
क्या हुआ?
उन्होंने रिजेक्ट कर दिया। मतलब उसमें 6 रिव्यूज आए थे, 6 में से 5 ने तो एक्सेप्ट करा था, 1 ने रिजेक्ट करा था, तो फिर उन्होंने रिजेक्ट ही कर दिया उस पे। और एक में रीजन ये था कि हमारे पास बहुत सारी सबमिशंस आ गई थी, तो इसलिए हमने फिर एक्सेप्ट नहीं किया। एक में रीजन ये था।
किसी और में नहीं भेजा?
सर अभी मैं एक जर्नल लिख रही हूँ, जर्नल के लिए, मतलब अभी मैं एक रिव्यू पेपर लिख रही हूँ, तो अब देखते हैं कहीं और भेजूंगी। मतलब मैं तो ये पूछा था, हमें पता कैसे लगेगा कि ये जर्नल सही है या ये वो है?
मैं इसको learners, let's wait for a few minutes, and if you have question, you can raise the question after 10 minutes.